You're looking at a smoking hole in the ground that used to be a masterpiece of aerospace engineering.
And I'm looking at the balance sheet. $100 million vaporized in less than 4 seconds.
It's not just the money, Elena. This machine was the apex predator of the skies. Mach 2 capability, thrust vectoring, advanced stealth.
And yet, it was taken down by something you could find in a jar in your grandfather's garage.
Exactly. We aren't talking about a missile strike or a bird strike. We're talking about a hardware store reject.
A washer, a 50-cent piece of stamped metal. That's the culprit.
That's the killer. A single non-spec flat washer slipped into a critical assembly.
It sounds like a bad joke. How does something that small ground a jet that costs more than the GDP of a small island nation?
Physics doesn't care about the price tag. It only cares about the weakest link.
So, walk us through the scene. What happens when that weak link snaps?
Imagine you're the pilot. You're at 30,000 feet, cruising speed. Everything looks green on the HUD.
Total confidence in the machine. You've got thousands of hours of training.
Right. You bank left for a standard maneuver. You push the stick. You expect the hydraulics to bite and the ailerons to move.
But they don't move. Or worse, they move too much.
They flutter. That tiny washer was supposed to space a bolt on the actuator arm. It gave out.
So the bolt has room to wiggle. That doesn't sound instant death lethal, Mark.
In a car? No. You hear a rattle. At supersonic speeds, that wiggle is a jackhammer.
Vibration. The silent killer of anything mechanical.
It starts as a hum, then a shake. Then, in milliseconds, the vibration frequency matches the natural resonance of the tail assembly.
Resonance. That's when the structure effectively tears itself apart from the inside, right?
Violently. The bolt shears. The control surface, the part steering the plane, disconnects completely.
So suddenly, the pilot isn't flying a jet. He's riding a falling brick.
Zero control. The aircraft pitches up violently, pulling maybe 12 or 15 Gs.
That's lights out for the human body. The pilot blacks out before he even knows he's crashing.
The airframe snaps under the stress. The wings fold. The fuel tanks rupture.
And then the fireball. All because someone saved a few pennies on a washer?
That's the mechanical reality. But you know the industry, Elena. How does a 50-cent part get into a billion-dollar supply chain?
That's the ugly part, Mark. It's never just an accident. It's usually a decision.
A decision to cheap out? On a fighter jet? That seems insane.
It's not insanity. It's logistics. Maybe the authorized part was on backorder for 6 weeks.
So a mechanic grabs something from the bin that looks right just to get the bird in the air?
Get it flying. That's the pressure. A grounded jet loses money. Or in a war zone, it loses strategic value.
But looks right doesn't fly in aviation. We have tolerances measured in microns.
Exactly. A standard washer might be made of soft steel. The spec called for hardened titanium alloy.
To the naked eye, they look identical. Under load, one holds, the other turns into putty.
And nobody checks it once it's installed. It's buried deep inside the fuselage.
So it's a ticking time bomb. It survives the first flight, maybe the second.
It sits there, degrading every time the pilot touches the controls, waiting for that one high-stress maneuver.
And when it fails, the investigation is a nightmare. The wreckage is scattered over 5 miles.
They have to find a washer the size of a quarter in a debris field of twisted titanium and burnt composite.
It's forensic engineering on impossible mode. But they found it.
They found it because the threading on the bolt was stripped in a specific way. It told a story.
The story of a soft metal being eaten alive by a hard steel bolt.
It brings up a terrifying question for everyone listening. How much of our safety relies on the honor system?
All of it. You trust the mechanic, the factory, the supplier.
And if one guy in that chain decides to cut a corner to save 5 minutes or 5 cents?
Then you have a crater and a funeral.
We need to dig deeper into the how. How did the mechanic miss it? Was it labeled wrong?
That's the terrifying part. It might have been counterfeit.
Fake parts in a military jet? That sounds like a spy novel, not a maintenance report.
It's a massive industry, Elena. Bogus parts flood the market.
So we have a mix of potential criminal negligence and catastrophic physics.
and a pilot who never stood a chance. The G-force data from the black box is horrifying.
I saw the report. The spike in vertical acceleration was off the charts.
The plane literally disintegrated mid-air before it even hit the ground.
Because a washer deformed, it compressed when it should have held rigid.
Once that gap opened up, the hydraulic arm had play. Slop.
Slop in the controls means death at Mach 1.
It causes flutter. Imagine holding a flag out a car window. It whips back and forth.
Now imagine that flag is made of steel and weighs 500 pounds.
It hammered the mounting bracket until it snapped. Clean break.
And the redundant systems? The backups?
Useless. When the primary linkage snaps, it jams the backup. The washer killed the fail-safe too.
That is a design flaw, but it was triggered by that cheap component.
It exposes the fragility of these high-tech beasts. They are strong, but they are brittle.
Complexity breeds failure points, and we just found the smallest, cheapest one.
It makes you think about every flight you take, every car ride.
Is the bolt holding my wheel on real, or is it a cheap knockoff?
Most people don't want to know the answer to that.
But that's why we are here, to look at the wreckage and find the truth.
The truth is usually simple, ugly, and cheap.
50 cents. That number is going to haunt me.
It should. Wait until we get into the autopsy of the mechanism itself.
I want to know who signed off on that maintenance log. Someone signed their name.
We'll get to the names, but first, we need to understand the violence of the failure.
The crash site photos look like a bomb went off.
Kinetic energy, a 30-ton object hitting the ground at 600 miles per hour.
Because of a washer. I still can't wrap my head around the scale.
It's the butterfly effect, but with jet fuel and high explosives.
Let's rip this apart. I want to know exactly how that washer failed physically.
I've got the technical diagrams right here. It's a study in material fatigue.
And I've got the supplier emails. It's a study in corporate greed.
Perfect mix for a disaster.
Let's open the file. Block 2 is going to get technical.
Strap in. It's going to get bumpy. Let's get into the forensic engineering, because the physics of this failure are brutal. The spec required an inconal superalloy washer, stuff designed to survive hell. It handles extreme heat and vibration without flinching. But the debris analysis proved the washer they found was standard 304 stainless steel. That metal is fine for a kitchen appliance, Elena, but inside a fighter jet tail assembly, it's like using chewing gum to hold a car engine together.
And here is how a kitchen appliance part ends up in a classified weapon system. It's called supply chain pollution. The primary contractor subs it out to a smaller firm, who subs it out again. By the fourth tier, you have a broker buying bulk generic washers for pennies, printing a fake mil-spec label, and selling them to the Air Force for $50 a pop. It's the highest profit margin in the narcotics trade, but legal.
A human, or something that needed a hammer.
That label was the only thing holding the plane up. When the mechanic installed that counterfeit washer, he torqued the bolt to 80 foot-pounds. Because the metal was too soft, it didn't hold the tension. It crushed. It literally flattened out like dough. So, effectively, the bolt was loose before the jet even rolled out of the hangar. The clamp load was 0 from day one.
That brings us to the human failure, which is just as fatal as the mechanical one. I pulled the maintenance logs for this specific tail number. 3 different inspectors signed off on that installation. 3 signatures. They didn't inspect the metal. They inspected the paperwork. We call it pencil whipping, picking the box just to clear the queue and go home.
Pencil whipping killed the pilot. As soon as he hit the afterburner, the vibration started. Without that clamp load, the bolt started to back out. It's called rotational loosening. Every vibration cycle nudged that bolt a fraction of a millimeter to the left. It took about 4 flights for it to back out enough to hit the hydraulic actuator housing.
It's terrifying to think about the timeline. That jet sat on the tarmac for 2 weeks between flights. At any point, someone could have walked by, wiggled the control surface, and felt the play. But the logistics system said green status. The computer said the part was new, so nobody bothered to put their hands on the machine and actually check.
They trusted the screen, not the mechanism. On the final flight, the pilot initiated a high G turn. The hydraulic ram pushed against the control surface with about 10,000 pounds of force. The loose bolt acted like a wedge. Instead of pivoting smoothly, the mechanism jammed. The hydraulics kept pushing until the main structural spar just snapped in half.
And looking at the financial fallout, it cascades. When the spar snapped, the investigation grounded the entire fleet. That's 200 aircraft sitting on the ground for months, while crews physically removed every single washer to test them. The operational cost of that downtime is in the billions. It's not just the crashed plane, it's the paralysis of the entire air wing.
The recovery team found the bolt 3 miles away from the main impact crater. It was pristine. It didn't fail. It was the washer that disintegrated. The witness marks on the bolt thread showed it had been hammering back and forth violently. It confirms the pilot was fighting the stick for maybe 3 seconds before the wing folded. He was wrestling a ghost.
Those 3 seconds are the difference between a mechanical failure and a tragedy. But let's look at the supplier again. The company that sold these parts dissolved 2 days after the crash. It was a shell company. No warehouse, no factory, just a P.O. box in a strip mall. They washed the money through offshore accounts before the smoke even cleared.
It makes you realize that high-tech engineering is incredibly fragile. We build these machines to withstand missiles and lightning, but we can't protect them from a guy with a stamp printer and a bag of cheap hardware. The system assumes everyone is honest. Physics proves that they aren't.
And the taxpayer foots the bill for the honesty gap. We paid for the investigation, the grounded fleet, the lost jet, and the wrongful death lawsuit. All because the procurement software automatically selected the lowest bidder without flagging that the price was suspiciously low for aerospace-grade titanium.
And the taxpayer foots the bill for the honesty gap. We paid for the investigation, the grounded fleet, the lost jet, and the wrongful death lawsuit. All because the procurement software automatically selected the lowest bidder without flagging that the price was suspiciously low for aerospace-grade titanium.
There's a rule in the shop. If you drop a part, you throw it away. You don't take risks. But in the office, the rule seems to be, if it's cheap, buy it. This crash wasn't an accident, Elena. It was an inevitability. You put soft metal in a high-stress joint, and it's just a math problem waiting to solve itself.
Exactly. And the math always ends in zero. 0 survivors, 0 value. We've dissected the machine and the money, but we need to talk about the future. Does this change anything? Or are we just waiting for the next washer to fail in the next billion-dollar prototype?
That's the question for the aftermath. We rebuilt the protocols, but metal has a memory, and so does the market. Let's move to the verdict and see if we actually learned how to survive this level of incompetence.
The aftermath wasn't just a funeral. It was an industry-wide purge. The Air Force initiated a zero-trust supply chain overhaul immediately after the report dropped. They froze purchases from thousands of vendors overnight. If a supplier couldn't prove the metallurgy of their bolts with a certified lab report, they were blacklisted. It crippled logistics for a year and cost billions in delays, but it finally flushed out the rats.
In the hangars, the culture shifted instantly. We stopped trusting the packaging. Now, critical fasteners often get non-destructive testing, NDT, before they even touch the jet. Mechanics are using eddy current scanners and X-rays on bolts the size of your pinky finger. It slows down maintenance hellishly, but nobody complains anymore. We all saw the crater photos. We know exactly what happens when you rush the small stuff.
But here's the scary reality for everyone listening. This isn't just an aerospace problem. That same global counterfeit supply chain feeds the automotive industry, medical device manufacturers, and elevator repair companies. If a shell company can fool the Pentagon, they can definitely fool your local mechanic. The lowest bidder algorithm is running the world right now, and it puts us all in the splash zone.
That's the survival takeaway here. Whether you're driving a truck, managing a factory, or just maintaining your own home, you have to verify your critical points. If a part fails, don't just replace it. Ask why it failed. Was it stress, or was it a fake part? Look at the grain structure of the metal. If it looks cheap, trust your gut. not the paperwork.
It brings us back to the core philosophy of Kinetic Fall. Complexity masks corruption. The more layers you have between the buyer and the maker, the easier it is to hide a 50-cent lie. That washer was a symptom of a system that values speed over substance. We effectively paid $100 million and a human life just to relearn a very old, very painful lesson.
And the pilot paid that price alone. That's the part that sticks with me. He did everything right. He flew the procedure perfectly. But he was killed by a procurement spreadsheet 3 years before he even took off. It's a grim reminder that in high-stakes environments, your safety gear is only as good as the integrity of the person who sold it.
So, the verdict: trust, but verify. And then verify again. Because in this economy, good enough is usually dangerous. Keep your eyes open on the logistics, because the smallest error typically carries the highest interest rate when the bill finally comes due.
Exactly. Gravity doesn't negotiate, and physics doesn't take bribes. Check your gear, check your people, and never assume the system is working just because the status light is green. Stay sharp out there.